Alright, I thought I'd go ahead and upload a part 3 to the progress of my homemade CNC milling machine. Now, I'm going to go ahead and show you what I did for my, I guess this would be considered the Z axis that moves up and down, because this column is going to be bolted up to the base of the machine I have over there. Now, what I did, I used linear bearings here. This is linear shaft right here, just on some angle. And I'm going to tell you guys right now, this stuff is tough. The bandsaw wouldn't even touch it. I had to cut it off and then face it with carbide in the lathe, and it didn't even like that. So, and this is kind of brings me to the point where I'm at here, because my initial prototype, I was running a Ryobi that I converted over here, a bench grinder, and I used a air grinder, you know, one of the cheapy air grinders to hold a 1/4 inch collet. Well, now I'm running it, I'm improving things, making everything more rigid because my proof of concept worked. So I'm trying to go from there, and this is just a cheap, I don't even know if they still make these anymore, but just a cheap Ryobi 6-inch bench grinder. And the thing that intrigued me here is the RPM. This thing will focus, is you can't quite see it here, 3600 RPM. So I want to get my spindle speed up, and I'm sure a lot of you guys would say, well, why don't you just do one of the Chinese knockoffs from China? Well, I have some routers, and I just detest the sound of the routers, and I'm not going to have a router running in my shop because it'll drive me absolutely batshit crazy. So here's my other option of a motor that I have here on hand. That is a just a Northern Hydraulic, basically a Harbor Freight 1.5 horse, but as you can see, it's much larger than that Ryobi. Now I'm kind of in a point here because I'd like to have a motor between this size and this size. So this is a 1.5 horse. If you do the math, I think this is a 1/3 or maybe even a 1/4 horse. So I'd like something in between, say a 3/4 or maybe even a 1 horse. But now the problem I'm running into, or my concerns are, in my lead screw arrangement I have in my prototype here, in this bearing block I have a support supporting the bearing for my lead screw here, which, mind you, my lead screw, I'm going to tell you guys right now, I am running, all my lead screws right now are 3/8 13, or 3/8, what the hell is it, 3/8 13 threads per inch. And on the servos I have, the servos I believe are 270 ounce servos. I've been able to get repeatability at 0.001 thousandth of an inch has not been a problem. I could probably even dial it in if I eliminate some of the backlash. Now, on my base that you can kind of see in the background, right there, I've actually have that's a genuine, has the half inch, or I'm sorry, it's a 1/2 inch 13 is what that is, not a 3/8, 1/2 inch 13 lead screw. I'm actually running a genuine thrust bearing and preloading the bearings. However, on the Z axis, it's just a cheap bearing that's, you know, really not intended to handle those kinds of loads. Now also for the linear bearing part of this, I'm using bronze bushings running on this 3/4 inch linear shaft or linear rod or whatever you want to call it. So really I'm kind of caught here. I'm almost contemplating, let's just bolt up this bigger motor, this 1.5 horse 3450, and I know they got variable AC drives out there. I may consider doing that, but I'm not sure with the weight. This motor's probably 3 times the weight of that motor if I'm going to run into motion issues here. And then I would have to upgrade my servo or possibly give it some mechanical advantage and change out this 1/2 inch 13 and maybe start looking at maybe a 5/8. But at that point, then I just will go true thrust bearing supports and actually tool it up for that. So I guess this would be a part 3 to my other 2 videos. At least that's what I think I'm on. And just to give you guys an idea of the materials that I'm using, this is the same box tubing that the base was made out of. This was a plate that I got from a family member that's not using it, and it actually was surface milled. Like, of course you can't see because it's all scratched up, but it was surface milled out flat, and basically the truest thing I have in my shop without having a grinder here. And it is, I believe, 3/4 inch thick. And then my angles were 1/4 inch. And then of course the shafts are 3/4 inch. The support that's holding my bushings are 1 inch. The motor pad will be 6 by, I believe, what is it here? 6 by 6. And I know this is true because I turned that on the lathe. So I faced both sides of it and then milled the register into here to get these pieces. So I'm kind of torn as to far as what I'm going to do. I think probably what I'm going to do is try running this like I said. And if it's not enough, then we'll go from there. But I'll show you my failures. And hopefully you learn from me. Hopefully you can improve on it. And this is part 3.